Hello and welcome to Microsoft Virtual Academy, where we're talking about developing for Windows 10, data binding in this particular session. My name's Darren May, I'm president and co-founder of ch2, and we produce next level digital experiences. To my left is Jeff Morgan.
Good morning, Darren. I am a developer with ch2, and we're going to get started with some data binding today.
Sounds good. Let's set some expectations around what we're looking for in terms of the audience here. We're looking for people who are interested in making universal Windows apps. That's what we're talking about, so that really makes sense. We're also expecting people to have basic C# knowledge and basic XAML. There's great resources out on Microsoft Virtual Academy if you want to go and brush up on those skills before proceeding. Some other recommended resources are dev.windows.com. This is your one-stop shop for everything related to developing for Windows 10. You can get the tools, you can get documentation, design guidelines, and so on. Go out, read, it's great. Okay, let's talk about data binding. So in this particular module, we're going to be covering classic bindings, compiled bindings, binding to collections, and then we're going to talk about this strange thing called MVVM. Okay, so let's dive straight into classic bindings. What are these?
Classic bindings. So it allows you to keep your models and your UI in sync without writing a bunch of code behind to do all the plumbing of updating like you did in previous.
So you mentioned models there. So models is obviously a construct where we keep data. And so fundamentally, bindings is a way of getting data displayed by a control. But it's not just restricted to data as well. We can also use binding to influence how information is shown. So we can also bind to properties such as font size or color or whatever. So it's not just purely about displaying specific data, but also influencing how it is being displayed.
Certainly.
So we kind of mentioned here that models implement iNotify property change. So that's a way that we can notify the UI that data's changed. And we'll cover that in a little bit more detail in a moment. And as we said, we can bind to properties, collections, or to other controls, which is actually pretty interesting. There's a few interesting scenarios we can explore there. We also have binding modes, which indicate how properties are updated. Why don't you run through that a little bit?
Right. So you can specify a few different ways for your bindings to be updated. You can have them be updated just from your model. You can keep your model and your UI in sync. So if one changes in the model, then that is persisted to the UI and vice versa. Or you can have it just do it once, right when you load up if you have some static data or something.
So one way, that means any updates in the model get pushed into the control.
Right.
One time means we look at the model just the once and we forget about it from that point forward. So there's an optimization there in terms of performance because we're not looking to refresh that. Two-way means that the model can push into the control and the control can push back into the model.
Right.
Perfect. Okay, sounds really useful. So what is this thing to which we bind?
Right, so you're going to bind to what's called a data context.
Okay.
A data context is think of it almost as a container for your data.
Okay.
You can put things in the container, and then all the controls can look at that container for their data to bind and display their information.
Great. So where do we find the data context?
You'll find the data context on every control, actually. Every control has a data context, including the page that you are on.
Okay, so that sounds key.
Right, so the page itself defines the data context. Usually that's where you would define where your model goes. And then it will actually filter down through all of the children controls with that same data context so that each to the elements.
Okay, that's great, but it sounds like we should be able to override that as we move in. We want to have individual controls have specific data contexts as well.
Certainly, sometimes you will want to override it in child controls, or if you have a nested part of your UI that just deals with a particular aspect of a model, maybe you want to kind of subset that.
Okay, great. So we mentioned iNotify property changed, and so the convention is anything prefixed with an I is an interface, so that defines a contract of behavior for us. And what we have here is an example of a class, bindable class, that implements iNotify property change. So why don't you walk us through this one?
Right, so a bindable class here implements the interface iNotify property changed. That interface defines the property changed event handler, event.
Okay.
And that gets fired any time that a particular value on your model changes, notifying all the controls or other elements that are bound to that object, that there's a new change, you need to update and display some new information.
What we're really saying is behind the scenes, binding is subscribing to the property changed event.
Exactly.
And so it gets a notification, and we pass something as part of that event that lets any listeners know what has actually changed.
Exactly.
Okay, great. So in this particular implementation here, we have the raise property changed method that introduces a kind of an interesting little attribute markup here on the property name.
Right, that saves you a little bit of extra code. So if you see in the set method of the observable string property we have at the top, you can see that it passes in a ref to a observable string private variable.
Okay.
But we didn't have to pass the actual name of the field in. That is actually brought in by the compiler using that caller member name attribute.
Okay, so what we're effectively doing is trying to reduce the amount of magic strings that we have to put into our code and maintain. Previously, we'd have to actually physically type that this was observable string that was changing. And of course, if anybody's like me, they'll reverse half the words and wonder, why the heck am I not seeing any of my data update? So
exactly, because the property changed events, when they are being raised by the system, are actually just strings. It is saying the property observable string has changed. And so it's not a direct property reference in this case. Here it is simply the string, observable string has changed. And then the UI needs to update.
So if we look at this code again, we can see here that the set method actually does a little bit of a nice check for us. It ensures that we don't raise property changed events if we're assigning the same value, so that we don't actually incur the overhead of updating the UI to just display the same information, which is quite useful.
Exactly.
Okay, great. Ooh.
Oh, fail.
I know. Where's the explosion?
Oh, double
no.
fail.
Oh dear.
Ah, there
it is. There's the explosion. Thank you, Barry. We've broken the wall. Okay. So now we're here. Here we are. We're going to talk about the actual syntax for binding. Why don't you walk through this one?
Right, so we'll start with the first one, just a simple binding to a property. The first one is simply the word binding, and then observable string, the property you want to bind to. In this case, we don't need to use the word path, which indicates the property you want to bind to. It's just by default, if you don't include any extra parameter there, it's just going to bind to the particular property name of observable string.
Okay.
And then in two-way bindings, this allows us to keep the UI and the model in sync. If either one of them changes, we simply need to pass the property mode equals two-way to enable that. And the last one shows that we can bind to a whole host of things. It doesn't have to be text. We can bind to the source property of an image. And your source property of an image in this case can just be the string path.
Okay.
And then the binding runtime will actually convert that into a bitmap image source and bind that to the control.
So what we're really talking about here is that binding is actually pretty flexible and can almost determine what actions it needs to take to convert something from one type to another. So there's basically a lot of built-in type converters for this classic binding.
Exactly. It's very loose, and it will try to bind any way it can, and in the end, it'll usually even default back to toString if it can't bind at all, just to give you something.
Okay, well, let's explore a little bit more about the binding syntax. And if we look at this slide, we can see that there are actually a number of properties that we can express as part of the binding syntax. So you mentioned path. So path is often implicit. We don't have to supply it unless we're building a more complex expression as part of our binding.
Right.
But we can certainly set that. We've got converter and converter parameter. Now, we briefly mentioned type converters, but these are actually for more custom converters, ones that some are included as part of the platform, others that you, the developer, can write your own converters if you need to change a Boolean value to a visibility or a color or something along those lines. Then you would build a converter. You can also pass parameters to the converter that may influence its behavior. Say, for example, you've got a bool to visibility converter. You might have a converter parameter that you turn around as is a flag that says invert the relationship. So true could be visibility.visible, but if you say invert the relationship, then true could be invisibility.collapsed.
Sure, gives you a little bit of extra functionality.
Okay, element name. Now that seems interesting.
Right, so element name allows you to bind to a different control on the screen. So if you have a text box, you can give it a name, and then you can use the element name binding on another control to bind to that text box.
Okay, great. So then we've got mode. We kind of touched on mode beforehand. We have one way here is highlighted red. So what we're telling everybody here that is the default behavior for classic binding is one way,
right,
which means the system will always be looking for changes on the model to update the UI.
Right, but if the UI changes, they will not be persisted to the model using one way.
So that's a gotcha. If you don't remember to set two-way up, then you run into a problem there that your data doesn't push back into your model.
Right.
Great. Okay, then we have target null value. So the name seems somewhat obvious, but there's some subtleties to this.
Right, so this is evaluated when you bind to a particular element and the value itself comes back as null. Maybe you don't want to display null, you want to display something like there is no data, there's some text value you want to display, you can use target null value to override that.
So for example, if we had imagined we had a model that was person, and we have first name, last name, and middle name. I, for example, don't have a middle name, so my target null value would be displayed if we tried to bind to middle name.
Exactly.
Okay, great. Then we have fallback value. So that we might think, okay, what's the difference between target null value and fallback value?
Right, so fallback value is going to be executed anytime your binding fails to run. If the property itself doesn't exist, because we're just using string representations to raise the property change, but maybe that property doesn't exist on your model.
Okay.
Then you will fall back to the fallback value.
So that seems to hint at perhaps a challenge with classic binding in terms of how can we be binding to something that doesn't exist? Well, we'll cover that in a little bit more, but in effect, what we're saying is it could well happen that this property isn't available on the objects, and we'll get to that in a second. Relative source.
Right, so relative source allows you to kind of traverse the hierarchy. So we said that you could change the scope of your data context on child elements. If you use relative source, that allows you in a child data context to access the parent's data context.
Okay, great. Then we've got update source trigger. That was new in 8.1 actually, wasn't it?
It was. A lot of times in binding to text boxes in 8.1, you would not get the notify property changed event until you actually left the text box itself. This allows you to override that and say, I want to update the model as soon as the property itself changes in the UI.
So by leaving the text box, you mean tabbing out to another control or clicking on another control. Effectively, you enter data and you have to lose focus before that happens. So that's an important thing to understand. Sometimes when we're building applications and UIs, we want to run validation to ensure required fields are populated, perhaps that the string matches a regular expression. Say we want to ensure that we're entering a valid email and so on and so forth. That because the data isn't pushed in until we leave the text box, that's typically when our validation is going to run in whatever code behind we're executing. So update source trigger allows us to change that behavior to say, evaluate as we type. So we can actually show not valid, not valid, not valid, yes, valid.
Exactly.
Great. Why don't we show a demo?
Let's look at some bindings. All right, so in Visual Studio here, I've created a small sample. Let's go ahead and run it and take a look at some of the different types of bindings. So you can see here to start off, I just have a simple binding that's binding to a model. We can take a look at that model here in a moment. You can see here I also have a two-way binding to that same model. And if I change the value in the UI, the model itself is updated.
Okay, so you're typing in that, so that also is using the update source trigger so we can see it updating?
It is. Otherwise I would have to lose focus on this box for it to update, but here I've told the update source trigger to update right away. In element binding, I have a text box and a text block next to each other. If I type in one box, you can see that it's reflected in the text box live. And then we don't have to do just text to text. We can, of course, use a custom converter to change types between different elements. So here I have a slider.
And the slider, its value is a double?
It's a double, right.
Okay.
But then the text box, of course, wants a string.
Okay,
so we have a custom converter taking that double, casting it to a string, and displaying it in the box.
Okay, does it work the other way?
Indeed it does. It is a two-way binding, so I can change the value in here, and it will change the string back to a double.
Okay, well, let's see how you've implemented that.
So first off, we'll look at the model that we were showing, our employee. We can see here we implement that same interface, the iNotify property changed interface.
Okay, so remind me, what does that bring in?
That brings in the property changed event handler. We need to go ahead and implement that along with our...
Yeah, it actually brings in the event, not the handler, and we have to create...
Right, the event. We have to create the handler. You're correct.
Yeah.
This is the same implementation we just walked through.
Okay. There's that little question mark, property changed invoked. That seems a little bit different than the way we'd normally activate an event.
That is a little bit different. Would you like to explain that a little bit with the new C#6 syntax as well?
Sure. So, in effect, what we would do previously, if we would check to see if property change was not equal to null. If it was null, it meant that there was no subscribers to that event, and so therefore we wouldn't want to raise it. The new syntax that's been introduced in C#6 allows us to evaluate whether a property or an object is null in the middle of a method chain. So in this situation, we're saying if property changed is null, don't invoke. If it is not null, rather, then we actually go on and we can invoke. And so this just allows us shorthand. It saves us having to clutter up our code with a bunch of null checks.
Great. We like short code. You can see here I have a couple of properties. I have an employee ID, a first name, and a last name. All of them are implemented the same way with a get and a set. The set is calling to that method that we talked about earlier.
Okay, so it's a generic method. It's being the type is being inferred by the compiler. So reft is going to always be the type of the property that we're calling. That's
exactly
great. And we've got the caller member name attribute there that, again, the compiler is injecting the string value at compile time so that we don't have to worry about typos.
Magic strings are gone again. All right, so let's look at how we implement the actual XAML for this page.
Okay, do you want to make that full screen?
I do want to make that full screen here.
Sounds good.
Okay. So at the very top, we actually are defining our data context here.
Okay, so we mentioned the data context was present on all controls. Typically, you're going to set it at page level and then override it as necessary beneath that, correct?
Right. So here, our employee data context will filter down to each control as well.
Look at that just for a second there, because one of the key things to understand about XAML is it is fundamentally an object instantiation language. And so what we have here is we're assigning to the data context property of our current page models employee. So that's actually going to create an instance of our employee model.
Correct.
And assign it to our data context.
And so if we actually look at the employee model, we can see here in the constructor, we set up some dummy values to give us some...
Yeah, so your real code probably wouldn't do that. You might be accessing a database or whatever it's going to be.
Exactly.
Great.
So the data context from the page is going to filter down into each one of these controls here, into the grid, into the stack panel, and all the way down into this internal stack panel, where you can see we bind to each one of those properties.
Okay, so those are properties that are expressed on the employee record.
Exactly.
Which is now in our data context. Okay. So looking at that first one, what do we know about the binding there? We know it's one way because that's the default.
One way by default.
Okay.
Exactly. These are the text boxes that were at the top, or I'm sorry, the text blocks that were at the top that were uneditable.
Okay.
In the next portion was where we could change the first name and last name, and it would persist those changes back to the model. You can see we specified it with a two-way, so those changes get persisted back.
Okay.
And we've also specified the update source trigger with the property changed.
So whenever the text property changes, we're pushing an update into our binding.
Exactly.
Great.
Getting into more complex scenarios, this is the element binding, where we had the text box looking at the text block, and they were keeping in sync with each other.
Okay.
So here you can see that I have given a name here to the text box.
Okay.
And with the text block, I have referenced that with an element name binding that is two-way, and I'm giving it to the text path of that element.
Okay, so this is another use for that path, and in this case we need to be explicit because we've got a more complex expression.
Exactly.
Right?
The last example was the slider going to the text box. So if you see here, we have a slider defined and a text box with the name custom text converter. We specify a element name binding to that using the two-way and binding to the text property of that text box.
Okay.
But then we also have a converter here, which some interesting syntax as well.
So show me where the static resource is defined.
So at the top, right below the page resources, where you usually find you will define your converters.
Yep.
A collection of them is usually in your page resources, or sometimes you can put them in your app.xaml if they're used throughout your app.
Okay. So there's a number of different ways we can manage resources, but here's the advantage of this one is we're scoping it to the page, so it's only going to be evaluated for this page.
Exactly.
Great. Do you want to show how that converter works?
Yep. So we'll go ahead and dive into the converter itself. I'm going to have to open it up here. So I have created a converters folder, and I have a string to double converter.
It should be noted, actually, if you pop your solution out there, that there's your Solution Explorer. You're following a great convention here of placing types of objects in certain folders so it's easy to find. So you've got your employee model is inside a models folder, you've got your converters inside converters. It's certainly strongly recommended that any non-trivial application mirrors something like this.
Exactly. Usually you would also have a pages or a views folder as well to keep track of all of your individual screens.
Great.
So in the converter, we go ahead and implement the iValue converter interface.
Okay, what does that tell us that we need to have?
So that brings in two methods, convert and convert back.
Okay.
Which
sounds like it might be around two-way.
It's around two-way, exactly. So if you have a two-way binding on a convert, it will run this, and on a convert back, it will run this method. However, if you are using a one-way binding, you will actually never use your convert back, and usually it is left.
That explains why I often see throw not implemented.
Exactly, yes. You will usually see a throw not implemented inside of here, and that's usually the common convention if it is just a one-way.
Okay, great. So let's walk through the convert then. Seems like that's interesting to do.
All right, so I'm taking in a value here, passed in as a variable.
Yep.
And then I'm going to try and parse that to a double, right? I'm taking the value from my text box, and I'm going to try and parse that into a double value.
Okay, so we've got a string that could be the character 5.
Right.
Okay.
And if that conversion is successful using the try parse, I'm going to go ahead and return that. If it didn't work, I am going to just return 0.
Okay.
Conversely, I could return null here as well, and the binding just wouldn't run.
Yep, I'm with it. And so we're using try parse here because that prevents us throwing an exception if we've typed Fred into the text box and we're trying to convert it into a double.
Good defensive coding here.
Okay, sounds good.
Great. So I think that covers converters there and a bunch of simple experiments with binding.
Okay, great. So the next thing we were going to talk about was compile bindings. And so compile bindings are new into Windows 10.
Indeed.
And they're actually a new syntax, so that it's x:bind as opposed to binding. And what's really the key difference?
It looks very similar to binding, but at the base level, it acts very different. Bindings are compiled rather than run dynamically at runtime, which means that if your types don't match, you run into a lot of different scenarios there.
Okay, so what we're saying is that the x:bind is compiled and strongly typed.
Correct.
Whereas the traditional classic binding is not compiled, it's evaluated using reflection at runtime. Now this comes back to the point we were making earlier, where it may be that a property doesn't exist in the data context for a classic binding, in which case we'll end up with nulls or the inability to evaluate a property. And that's a product of the flexibility that's inherent in the fact that it uses reflection to find these things. We often refer to that as duck typing, where duck typing basically refers to if it walks like a duck and quacks like a duck, it's a duck. And what it really means from that perspective is if we turn around and bind to a property that we call first name, we're not saying where that first name property needs to be. As long as the object in the data context has a property called first name, then that's what we're going to bind to. So it could be bound to an object called Jeff, it could be bound to an object called Darren. Either way, we have a first name, and that binding would work.
Exactly.
When we come across to X binding, it's strongly typed, and now we need to turn around and be very explicit around the object type that we're binding to, as well as the property names.
But obviously, we're getting something in return for having that strongly typed, and that is speed.
Yeah. Reflection, unfortunately, takes time to evaluate. We search through metadata, we cast objects, and so on and so forth, whereas what the strong binding in xbind provides is a bunch of very concise generated code that's built by the compiler by tooling at compile time that then just executes in an optimal fashion during runtime.
great.
Of course, there are trade-offs. As we lose flexibility, that means we sometimes have to do more work. For example, there is limited support for converters, and we don't get as much IntelliSense right now as we do with classic binding.
And I should say for built-in converters. You can still write your own.
Yeah, absolutely you can. And in fact, you write them in pretty much the same way as we do and just demonstrated for classic binding. The other key thing is it's scoped to the page level rather than to page.data context. And the reason for that is page.data context is an object. It's defined as an object, so it's inherently not strongly typed, which means it's not a good candidate, it's not even a valid candidate to use with X binding. Instead, we have to have other properties on our page that we bind to. And by convention, we're tending to settle on creating a strongly typed view model property that people bind to. And we'll talk about that a little bit more. There's another key difference about the compiled binding, and that it is set to one time by default as opposed to one way.
That's a big gotcha, because you just won't see your bindings update, unfortunately, and won't have a good reason why.
Yes, it's not evident if you're used to the classic binding approach that's what's gone wrong, because you look at your code and you just say, oh, why, I just dropped Xbind in there, why doesn't it work? Well, it's for efficiency again. The whole purpose for Xbind is to make binding as fast as it possibly can be, so it doesn't create extraneous code. You have to be explicit about your desire for that extra code. So if you wish to have the additional code that supports one-way binding, then you need to explicitly state that. The other challenge to a certain extent is that compiled bindings can't be created programmatically. They have to be expressed in our XAML.
Right, with classic bindings, if you wanted to, you could create a binding in code behind and apply that to an element. But you can't do that with compiled bindings because they're compiled.
Sounds good. So we mentioned they use exactly the same notification mechanism as previous bindings. So iNotify property changed. It is unchanged for Xbind. Let's look at some syntax examples.
So you'll notice the syntax is pretty similar. We're simply changing out binding for Xbind. We can bind to the same observable string. In the first instance there, that's going to be a one-time binding. It's going to grab the value from the model the first time, and then that'll be it.
Yep.
Two-way binding, we can simply add the mode two-way. And then collection binding, something we haven't quite talked about yet. They also have a little bit of a change from how you do a classic binding in that you need to specify a data type in your data template. And we'll go over that a little bit more here in a bit.
Okay, but that in effect allows the data template to be evaluated in a strongly typed fashion rather than being implied.
Exactly.
Using duck typing. Okay. So let's take a look at the properties. So this is a pretty similar list to what we had with classic binding. But what we can see is a number of the options on here are struck through. So path is the same as it was.